Ayrton shunt ammeter. This is a type of ammeter which is used to extend the range of the ammeter. Ayrton shunt ammeter is also called as a universal shunt meter. It is nothing but a multi-range ammeter. Ayrton shunt ammeter is shown in the figure. When the other type of ammeters are used, like an ordinary ammeter or an ammeter with a make before break switch or a multi-range ammeter, when we change the ranges of the ammeter, in that no resistance will come in parallel with the de-Arcelor moment, which is highly sensitive meter. When high currents flow through that meter, the meter gets damaged. So while changing the range of the ammeter, the problem arises that from one range to other range in the fraction of second, no resistor is coming in shunt with the ammeter and high currents flow through the meter gets damaged. So, Ayrton shunt or universal shunt ammeter is a high resistance shunt meter. This is used to increase the range of the ammeter without changing the damping. Multi-range ammeters which use this technique are more accurate than those using make before break switch. It eliminates the possibility of meter without a shunt, which is a serious problem. In the figure shown, when all resistors are in parallel, then maximum sensitivity. In the Ayrton shunt circuit, the selector switch changes the amount of resistance in parallel with Rm. The voltage drop across the parallel branches is always equal. Now, this is the Ayrton shunt ammeter. The positive and negative are connected to the circuit where the current has to be measured. The meter with internal resistance Rm and the current through the meter Im is connected in shunt with resistors Ra, Rb and Rc. For example, this meter can be connected to measure the currents with different ranges of 1 amp, 5 amps and 10 amps. So, when this meter is in the 1 amp range, the switch is in such a position that it has connected to 1 amp range, then Ra, Rb, Rc put together, 3 are in series. So Ra plus Rb plus Rc will come in parallel to the meter. Next, if you connect the switch to 5 amps range, then the resistor Rc will come in series with the meter. The meter and Rc together come in parallel to Ra plus Rb. Next, when the switch is in 10 amps position, then Rb, Rc and meter are in series. They are in parallel to Ra. So this is how the construction of the Ayrton shunt ammeter is. Next, supposing we design this Ayrton shunt with ranges of 1 amp, 5 amps and 10 amps with a meter resistance of 50 ohms, then let us see how to calculate Ra, Rb and Rc. As I told you, let us assume the full-scale deflection current of the meter is 1 milliamp. Using the above data, let us design the Ayrton shunt. It is nothing but calculating the values of Ra, Rb and Rc. Supposing we take the 1 ampere range. As shown in the figure, Ra plus RB plus RC are now in parallel with the 50 ohms meter movement. Now the meter requires 1 milliamp for the full scale deflection. The shunt will be required, the shunt resistor will be required for a current of 1 amp is the range required, 1 milliamp is the current through the meter. So the shunt resistor has to bypass a current of 999 milliamps. To calculate the resistors of RA, RB and RC, we can calculate this as 1 into 50 by 999. We have already seen this. This formula is nothing but Im Rm by the total current minus the current through the meter. It gives a value of 0.05005 ohms. Next, supposing I select the range to be 5 amperes, then the resistors RA and RB will come in parallel with RC plus RM. So now the current through the meter is, as I told you, it is 1 milliamp. The remaining current of 4999 milliamps should pass through RA and RB. So here the RA plus RB values are nothing but 1 into RC plus 50 ohms divided by 9999. Next, for 10 amps range now, RA is now in series as the shunt. So RB plus RC are in series with the meter. The current through the movement is 1 milliamp. The shunt passes the remaining current of 9999 milliamps. As we have already seen, RA can be calculated as 1 into RB plus RC plus 50 ohms divided by 9999. So when we solve these three equations for RA, RA plus RB, RA plus RB plus RC, we obtain the values of RA to be 0.005 ohms, RB to be 0.005005 ohms, and RC to be 0.04004 ohms. Such a small values, such a small resistors, when these are connected in shunt to the meter, we get nothing but the Ayrton shunt. As we already discussed, the precautions to be taken while using an ammeter is always connect an ammeter in series with the load. This has a very low resistance within the meter. So while connecting, select the proper range. And the important thing is always connect with the correct proper polarity. Don't reverse the polarity, which may damage the pointer and the ammeter. So take care to connect the positive and negative terminals carefully. The last one is nothing but, as I told you, when we are using a multi-range meter, you first switch it on into the highest current range, then you can decrease the range to whichever the range required. So these are the precautions to be taken while using an ammeter. So we have seen that the advantage of Ayrton shunt ammeter is it avoids the meter to be without shunt resistor when changing the range of the switches. One more thing is we can use a switch called as the make before break switch, so that when you're changing the ranges, first the next range is made before the last one is removed. So this is how you can use the Ayrton ammeter and avoid the damage of the ammeter.